This week we're going to be dealing with experiment 17, which is the Eschweiler-Clark methylation of an amine functional group. And it's a nice procedure. It allows us to methylate that amine group without over-methylating it. And it turns out that amines are pretty good nucleophiles. So if you'll recall back from lecture, if you start off with an amine, in this case we're going to look at a primary amine, and we react that with some type of alkyl halide, we can get an SN2 reaction to occur where the nitrogen functions as a nucleophile and displaces the leaving group of the alkyl halide. In this case, I'm just looking at methyl iodide, a very simple alkylating agent. And essentially what we get out of that reaction is a secondary amine plus an acid. And if we have a way of removing that acid from solution, we have, again, a second good nucleophile. And this nucleophile now is actually a little bit better than the primary amine because of this electron donating ability of the methyl group. And so this process will repeat and keep going until you get to the tetraalkyl ammonium salt, which precipitates out of solution. So that drives the reaction to the tetraalkyl ammonium salt. And so it turns out that if you're interested in making tetraalkyl ammonium salts, this is the way to do it. However, if you're trying to make a tertiary amine, for example, you're never going to get it because it'll go all the way to the tetraalkyl ammonium salt. And that's where the Eschweiler-Clark methylation reaction comes in. It's actually a nice way to stop at the tertiary amine and avoid this overalkylation problem. And so what we're going to do this week is a reaction where we start off with a primary amine, and we're going to use a mixture of formaldehyde. This is the aldehyde that's used in biology to preserve specimens and things like that, and formic acid. And formic acid is the acid that you get when a fire ant bites you, for example. So it's the stinging acid, so don't get this in your eyes, it will sting. We're going to use a mixture of formic acid and formaldehyde, and what we're going to get out of this reaction is a tertiary amine where the nitrogen has two new methyl groups on it, and it's lone pair. It will not overalkylate to the salt and precipitate out of solution. And this reaction occurs very easy. You mix these things together, basically heat them up, and you get the product. The yield here is very good, and this procedure is adapted from a Journal of Chemical Education paper that you need to read before coming to class. So make sure you get that downloaded. You have to use the USM Campus Network. Make sure you get that paper and read it before coming to class. It's only about a page and a half long, so it shouldn't take that long. So the mechanism for this particular reaction can be thought of as the amine reacting with the electrophile to break that weak pi bond, and in the process picking up a hydrogen from the formic acid. So this carbon right here came from the carbon of the formaldehyde. These two hydrogens are the two hydrogens on the carbon. The oxygen from the formaldehyde, and this hydrogen came from the formic acid. And so that gave us formate, if you will. So this is what we have at this point. Now, if you look at this, this looks like you've got an alcohol with a positively charged nitrogen. So these hydrogens should be fairly acidic, and so it's easy to imagine losing water in this reaction to give what's known as an iminium ion, so nitrogen doubly bound to a carbon. Now here's where the interesting stuff happens. This you're probably very familiar with from class. However, at this point, we've got to reduce this double bond to make it a single bond. And the way to do that is to use the formate. The formate is a good reducing agent. And the way that this works, let me erase it there and bring it over here just a little closer to where we need it. And so what happens is the formate will lose carbon dioxide and transfer a hydride to that carbon that's bound to that positively charged nitrogen, bringing those electrons to that positively charged nitrogen, giving us a secondary amine. Once we have a secondary amine, all we have to do is repeat this procedure. The secondary amine will react with the formaldehyde. The formaldehyde will get protonated by, or the alkoxide from the formaldehyde will get protonated to give us something that looks very similar to this. We will lose water once again, and formate will then reduce that, and you'll end up at this point. Once you're here, this cannot add to the formaldehyde and give you the aminium intermediate, and that's why it stops at this particular stage. And this works very well. You're going to be mixing these together and heating them up at a fairly high temperature. You should see rapid bubbling because as this process works, you're losing carbon dioxide, of course, which is a gas, and you will actually see your reaction bubble quite vigorously in the process. So make sure that nothing bubbles out of the flask, that you don't add the reagents too vigorously. Follow that procedure pretty much so to the letter as it's listed in the manual, and you should be okay.